today, I'd love to introduce you to our two presenters. Our session today, of course, is called The Development of an Interactive Open Educational Resources Website for Engineering Courses. And today we have Samer Adib, who is a professor and associate chair of undergraduate studies at Civil and Environmental Engineering. And we also have Lindsay Westover, who is an assistant professor in mechanical engineering with the Faculty of Engineering. So I'll hand it over to both Samer and Lindsay to get started, and look forward to your session.
Thank you, Krista. We're here today to talk about the development of our Engineering Open Educational Resources website. I'm very happy with how the university is celebrating our commitment to teaching and learning. And I'm going to maybe start by asking Lindsay to maybe introduce herself.
Sure, yeah. Thank you very much. I'm, as Krista said, an assistant professor in the Department of Mechanical Engineering. I joined in 2018, and I teach a few different courses in numerical analysis and vibrations, and I do research across kind of a broad spectrum in biomechanics. Samer, maybe you can introduce yourself as well.
So I'm a professor in civil and environmental engineering. I've been a professor here since 2007. I teach numerical analysis, solid mechanics, finite element analysis. I do research in both pipelines and biomechanics, and I've done a lot of administration. I was associate chair of undergrad studies. Before that, I was research and planning, and I was interim chair as well for a year.
And Samer, maybe you can also talk about your newest administrative role.
Oh, thank you for bringing that up, Linz. I'm very fortunate to have been appointed by Dean Brooke Milne to be Associate Dean for the Faculty of Graduate Studies and Research. I'm very excited about this role, and hopefully the work that we've done can also be part of the work that I'll be doing with FGSR. All right, Lindsay, so tell us, what are we going to talk about today?
So we'll go through a bit of the motivation for kind of why we developed the open educational resources, and then we'll go through what we've developed in engineering with our OER website, looking at some of the layout and kind of how it's put together and how it can foster collaboration. Go through a little bit of some of the feedback that we've received, and then some final remarks. So first, let's maybe Samer, you can provide a bit of the background and motivation for how this started.
So a while ago, I registered for some classes at an older age, and I remember sitting in the classroom, and at that time, the way of transcribing the information was done in the very traditional way, where I had to write the information following what the instructor was writing on the board. And I found, while this was how my traditional education was in the past, I found that it was a little bit impractical in this day and age. There's a lot of information that is lost when copied, not clear. There are some mistakes that when I write, I copy some mistakes, and there are also, for sometimes I'm not able to attend the lecture for whatever reason, and then I kind of lose that information. Now, of course, there is the idea, there's the information can be transcribed through textbooks, traditional textbooks, and I'm going to let Lindsay tell us what is the problem with textbooks.
Yeah, absolutely. I mean, so books have are obviously used in a lot of courses and can be very useful, but they do have some major limitations. For one, they can be quite expensive, so that can be cost prohibitive for some students and reduce accessibility. Sometimes the scope of the material is not appropriate for your course. So, you just want to cover a small portion of the textbook, but students need to buy the whole thing. Or maybe you need to use multiple textbooks to make up the content for your course. One of the major limitations of traditional textbooks is that they're static. So you can't have interactive examples, you can't have dynamic content, and in particular, updates and revisions are much more difficult. So maybe Samer, you can talk about kind of how your original website was used to address some of these limitations.
Yes, thank you, Lindsay. We started looking at open educational resources for engineering courses actually 2012, 2013. I developed the first website, and through that I was teaching 3 courses. And then more recently, when I started getting into administration, we wanted to have this service kind of available to other professors. And the important thing is there was lots of issues and that I had to overcome at the beginning to be able to publish my work in an open educational platform. And we just wanted to make it easy for other professors to actually post their work as well if they're creating a content. And so we based on the old website that we developed a new one that is open for all professors who want to add content, to make it affordable, accessible, interactive, and dynamic, and very easy for professors to add content to. Maybe, Lindsay, you, as a user and a person who actually added content, lots of content to that website, maybe you can tell us about the general layout?
Sure. So when you first land on the site, there's a little bit about the objective of the website. And then on the left-hand side, the menu here, you can see it's organized into different books. So the books can be a topic, it can be a course, it can be lab or tutorial sections. And then when you click on each of those books, it takes you to the actual book page. So inside each book, the landing page of each book has the contributors listed on the bottom. So most of the books that are currently available have multiple contributors. And then the menu on the left-hand side updates to the chapters for that particular book. And each of these sections that you can, if you can see the little arrows next to them, can be expanded out for the different subsections. And then on each page, within that, you have the page content. And so the page content, some of the examples we have right now have the learning outcomes maybe at the top. There's the text, obviously, which includes the course content. There's, we can have embedded quizzes. We have interactive examples where you can update the numbers and see what happens. We also have some embedded videos, which is especially useful this past year, teaching kind of in a hybrid online situation. So the small lecture content can be recorded and then embedded in the website. And there's an opportunity for students or other people to leave comments. And then when you expand out each of the subsections, you get the page contents. So these, the chapter contents, all of the headings have these automatic links that can get to the particular sections within the page.
So how would you use those links, Linz? Why would you need them?
So when you create the headings in a page, it creates this automatic link, and you can see that it actually changes the link in the search bar or in the address bar at the top. So it's very useful for navigating the page, and it's also really useful for like answering students' questions. So if a student has a question about a particular section, you can copy the link to that and reply in an email or something, and it can take them right to the section that you're talking about. So it's helpful in that way. So Samer, maybe you can talk a bit about the JavaScript quizzes that you have implemented in your courses.
Yeah, thank you, Linz. What happened is when we started when we transitioned to online delivery, we created a lot of content that was behind the eClass system. And as I was creating this content, I was creating links to the website or links to the content on the website, but then I was creating quizzes inside eClass just for students to check their understanding. And what I realized is in the future, when I have to recreate this again for next year, I will have to do lots of work to transfer that whatever content I created inside eClass to the new eClass. And to me, it looks like perpetual work that is not needed for just these quizzes that just are there to test for students to test their understanding. So we commissioned a couple of undergrad students to create some templates so that we can actually have very quick way of having those quizzes available on the websites. So in fact, in certain, not for all, of course, not of all the content, but we already have in one of the books, we have templates for quizzes. So at the end of each section, there's a quiz. And I had a very good TA who created some videos to explain how to answer these quizzes. We also embedded those solution guides underneath each quiz.
And maybe you can talk about some of the interactive examples. I know this was one of the things that first kind of drew you to developing these resources online.
Absolutely. I think what is the biggest driver behind the open educational resources with this particular, these interactive examples, which are very, very useful in STEM education, because which relies on problem solving, where there's some algorithms, there's some numbers, the student inputs, and there's algorithm, and there's an output. We created, because of the technology exists, we attempted to convert as many examples as possible instead of being static, but into dynamic examples where the student can change the numbers and then they can see the effect on the solution. And maybe at the end, if someone is interested, we can show them a live demonstration. Maybe Lindsay, you created a multitude of examples in your numerical analysis course. Maybe you want to go through that particular example that you have here?
Yeah, sure. So I did this for, we've done this for quite a few of the examples in the numerical analysis course. So this is just a simple example demonstrating a numerical integration. So the example just has a slider on it here that the students can change and see dynamically right away how that affects the numerical approximation of the integral, and visually can see what that is doing when they change the number of panels used to approximate the integral.
So one of the things, Lindsay, I know is for numerical analysis, there's a lot of people who prefer to use Python, others who prefer Mathematica, and others prefer MATLAB. So what have you done about that for your numerical analysis course?
Yeah, so the other thing that we've implemented in the website is embedding code snippets. So in particular, in a few of the books, but in particular the numerical analysis book, we have all of the examples require some sort of coding. And we want to provide this code to the students so that they can not only see the result of the example, but also see how it was solved and to use that code for their understanding. And in the course that I teach, I get them to use MATLAB, and then another course that I teach, I let them use whatever software they want. So we've embedded the Mathematica code as just a drop-down that you can see, look in this gray box here. There's also Python code available for the same examples, and then there's the MATLAB code available that the students can download. So they can, it helps also if they want to learn a new language, they can kind of see that translation from one language to the next for these simple examples. So Samer, maybe you can talk a bit about the commenting feature of the website.
So this is what was one of the things that were implemented in my older website, and I really carried over here, which is giving the ability for users, or for those who are browsing the website, to provide comments. And this has been extremely useful because whenever there's a small mistake or a typo or something that's not clear, we get those questions. And those questions we can immediately respond to, maybe make something more clear, or correct some typo, or correct something. This has been extremely beneficial. In fact, I argue, based on the older website that I had comments from all over the world, people from everywhere commenting on the wealth of examples, and some people requesting other examples and things like that. And it was very humbling and actually very very useful. And so we've implemented the commenting here in this website as well.
So Samer, when we moved to making this open for the professors across different engineering departments, can you talk a little bit about how that was done and how you might help a new professor who would be interested to get involved?
So absolutely. I mean, one of the biggest hurdles for any professor is their lack of time to try and learn a new platform. And so what we've done is, number one, we've provided a lot of, for those who want to do it themselves, we provided a lot of manuals, how to put the interactive graphs, how to use VPython, the templates for the book, auto numbering, how it's done, the quiz, we provide templates for the quizzes. So we have these manuals and templates for professors who want to do it themselves. In addition, thanks for the support of the Faculty of Engineering, we've hired for the past little while undergrad students and co-ops who helped digitize content. They helped create the manuals. They helped also program the interactive examples and also create some YouTube videos that we added to the website. In fact, these are the numbers of undergrad students that we've had since summer 2020. We've had a multitude of co-op students, and they all really enjoyed their experience of actually building that content from a professor's perspective rather than from, they've always been students. They've only looked at these content from one side. Now they've experienced it from the other side. So it was a very good learning experience for the students, and for us, it was very good relying on their energy to create a lot of the content that's available. So Lindsay, maybe you can tell us now about the collaboration. How you've used this a lot with numerical analysis and everything. Can you tell us, has this been instrumental in collaboration?
Yeah, absolutely. So one of the sort of thoughts when moving to the Eng Courses website was to encourage different professors to work together to develop the resources and to use the resources, to use the common resources for content that is common either within the same course or across different courses. So if you look at the books that are available on the site, you'll see that there are multiple contributors for quite a few of them. So for example, the first year statics course is taught by 4 or 5 professors at the same time each year. And so you can see that most of them available or shown here as contributors to this book. There's also a postdoc that contributed a significant amount to developing this book, as well as a professor from MacEwan University. Another example is the numerical analysis book, as you mentioned. So a numerical analysis course at the undergraduate level exists in most of the engineering departments. It has a different name, but it's essentially the same course. So this allowed us to use basically the same content and have multiple people contribute to these resources. So originally, the numerical analysis notes, the majority of it came actually from you, Samara, based on Dr. Dow's resources. And then I expanded it into the mechanical engineering course, and more recently in this last semester, collaborated with Dr. Lee, who was teaching the civil engineering course. So it has allowed us to kind of work together to develop some of these resources. So I know, Samara, you've been using this OER for quite some time now, so maybe you can provide just an idea of some of the feedback that you've gotten.
Yeah, thank you, Lindsay. The feedback was actually overwhelmingly positive. I've put here some of the feedback that I got just in the fall of 2020, but the feedback, in fact, the availability of these resources had made it extremely easy when we started teaching online. And in fact, I would like to say that my teaching evaluations in the fall of 2020 were actually in my undergrad course were the highest I've ever received in my whole career. Even though students have always liked the availability of these online resources, they actually really appreciated them, particularly in the fall 2020. And I think, Lindsay, you also have some examples of feedback that you received.
Yeah, I had a similar experience. So teaching from these resources, students found that I had very positive feedback. Students liked the availability of the resources, the organization, and kind of the sort of the wealth and variety of material that was available.
Of course, with anything, there's, with any educational resources, there's limitations. And I'm going to start with the first limitation that Lindsay encountered. Maybe Lindsay can tell us about it, where the difference in teaching styles and how it might be a hurdle in adopting open educational resources. So give us.
Yeah, absolutely. So, one thing that can be that can come up, especially if you're having multiple people use the same resources or contribute to the same resources, is differences in teaching styles. So, and even just differences in notation. So this is just a simple example from vibrations, where in the majority of textbooks, the natural frequency of a system is denoted by this symbol omega. And the way that I teach it and the way that my former supervisors teach it is to use a symbol P. So something simple like that can sort of cause a bit of conflicts in terms of notation and differences in these styles.
Yeah, thank you, Lindsay. And another example is incorporating rigor. I'm just going to say that, just mention an example where one of our best professors actually at the university, where I was trying to work with him on incorporating some rigorous explanation to some materials in one of the textbooks. And while I prefer to have the rigor first, very visible to the student before the examples, he rightfully likes to have the examples first and then the rigor maybe following later. So things like that might preclude people from adopting different open educational resources that's developed by others.
Yeah, so thanks a lot, everyone, for listening. I think there's some questions in the spreadsheet there, and so we can maybe go through those and take any additional discussion as well.